One of the key results in statistics is the central limit theorem. For our purposes, the central limit theorem goes as follows. When we take a sufficiently large sample of n independent observations from a population with mean, mu, and standard deviation sigma, then the sampling distribution of the sample mean, x bar, will be nearly normal with mean mu, the same as the population mean, and standard deviation, what's called the standard error, which is sigma divided by the square root of n. Now the challenges in the central limit theorem are, one, defining what a sufficiently large sample is. And so the usual rules for us will be if the sample size is less than 30 and there are no clear outliers in the data, then we typically assume the data comes from a nearly normal distribution. If the sample size is at least 30 and there are no particularly extreme outliers, then we typically assume the sampling distribution is nearly normal, even if the data is not. And generally, we're going to make this assumption in the course. And if you're interested, you probably need to take a full course on statistics. Second, the observations are independent. The most common way to satisfy independence is through a simple random sample of the population. Again, we're generally going to assume independence, and if you're really interested in this part of the course, then it's probably worth taking a full course in statistics. Finally, we are going to have a problem, which is that generally we don't know the standard deviation of the population, and so we can't calculate standard error in this way. So we are going to have to estimate standard error, and this affects some of the analysis that we do. Now, in the previous section, we had a couple of examples. We were drawing from a uniform distribution, and we were either taking 10 samples and looking at the average of those, or we were taking 20 observations and looking at the average of those. Now, the standard deviation of the uniform distribution between 0 and 1 is the square root of 1/12. That means that the standard error for samples of size 10 is the square root of 1/12 divided by the square root of 10. The standard error for samples of size 20 is the square root of 1/12 divided by the square root of 20. And the standard error is the standard deviation of the sampling distribution.